In this part of the discussion, I will show you how to draw the formation of the image on a convex lens. An object of 3 cm height is placed in front of a convex lens. The focal length of the convex lens is 6 cm. Draw the formation of the image if the object is placed A. 4.5 cm in front of the convex lens, B. 9 cm in front of the convex lens. Use the scale 1, 2, 3. It means that 1 cm in the drawing represents 3 cm in the real measurement. Number 2. State the characteristics of the image in 1A and 1B. Number 3. State the distance of the image from the convex lens by measuring your drawing. Let's begin. Drawing number 1. First, draw a horizontal line. This horizontal line is called the primary axis. Then, draw a vertical line. This vertical line represents the center of the lens. Next, draw the position of the optical focal point for both sides of the lens. We use the scale 1 cm on the drawing represents 3 cm on the real measurement. So, the optical focal point must be drawn 2 cm from the lens for each side of the lens, like this. Why it must be drawn 2 cm from the lens? Because in the problem it is said that the focal length of the lens is 6 cm. So you divide 6 cm by 3. Because once again we use the scale 1 cm in the drawing represents 3 cm in the real measurement. Name the right side as F1 and the left side as F2. The naming is made to show that F1 is the active focal point. The active focal point is the focal point to where all parallel rays of light converge. The assumption for the drawing: the left side is the front part of the lens, while the right side is the back part of the lens. Draw the position of 2F1 and 2F2. The distance of 2F1 from the lens is twice the distance of F1 from the lens. The same condition applied to F2. Draw the object. The object is 3 cm high. So based on the scale we use, we have to draw it as 1 cm. The distance of the object is 4.5 cm from the lens. So based on the scale we use, the object must be drawn 1.5 cm from the lens on the left side of the lens. This is the object. Please remember, the height of the object must be drawn as 1 cm. The distance of the object from the lens must be drawn as 1.5 cm. Now let's draw the rays. The first ray is drawn parallel to the primary axis, passes through the tip of the object until the ray meets the lens. Then this ray will be refracted to the active focal point F1, like this. The second ray must pass through the tip of the object and the vertex. The vertex is the point where the primary axis and the center of the lens meets. This ray will not be refracted. Instead, it will continue as a straight line. The tip of the image is supposed to be at the intersection of the refracted rays. On this drawing, the refracted rays will not intersect on the right side of the lens. You can see here that they are getting farther from each other. So, we have to extend the first refracted ray, this one, to the left side of the lens, like this. Usually, we use a dashed line to extend the refracted ray. Now we can find the point where the refracted rays intersect. So, the image can be drawn like this. Remember, the tip of the image must be positioned at the point where the refracted rays intersect. From this drawing, we can conclude that the characteristics of the image are virtual, upright, and enlarged. Why virtual? Because the image and the object are on the same side. It is upright and enlarged. Now measure the distance from the image to the lens. You measure this distance. If your drawing is correct, the distance should be equal to 6 cm. Since we use the scale 1, 2, 3, then we have to multiply 6 cm by 3 to get the real distance. So, the real distance of the image from the convex lens is 6 times 3, which equals to 18 cm. So this is the answer to our first drawing. Let's continue to the second drawing. Just like on the first drawing, first draw a horizontal line, which is called the primary axis. Then draw a vertical line, which represents the center of the lens. Next, draw the position of the optical focal point for both sides of the lens. We use the scale 1 cm on the drawing, represents 3 cm on the real measurement. So the distance of the focal point from the lens is 2 cm for each side. Name the right side as f1 and the left side as f2. Remember, f1 is the active focal point. Now draw the position of 2f1 and 2f2. Once again, the distance of 2f1 from the lens is twice the distance of f1 from the lens. The same condition applied to f2. Draw the object. The object is 3 cm high. So based on the scale we use, we have to draw it as 1 cm. The distance of the object is 9 cm from the lens. So based on the scale we use, the object must be drawn 3 cm from the lens on the left side, like this. The height of the object is 1 cm. The distance of the object from the lens is 3 cm. Let's draw the rays. The first ray is drawn parallel to the primary axis, passes through the tip of the object until the ray meets the lens. This ray is refracted to focal point f1. The second ray must pass through the tip of the object and the vertex. This ray will not be refracted. Instead, it will continue as a straight line. The tip of the image is supposed to be at the intersection of the refracted rays. The refracted rays intersect at this point. Then this point will be the position of the tip of the image. So we can draw the image like this. Based on this drawing, we can conclude that the characteristics of the image are real, inverted, and enlarged. Why this is a real image? Because the image is now on the opposite side of the object. Now measure the distance of the image from the lens. If your drawing is correct, then this distance should be equal to 6 cm. Since we use the scale 1 cm on the drawing represents 3 cm on the real measurement, we have to multiply 6 cm by 3 to get the real distance. So the real distance of the image from the convex lens is 6 times 3, which equals to 18 cm. It is just a coincidence that the distances of the image from the lens for both drawings are equal. It is possible that they can be different. This is the end of our discussion today. Don't forget to do the assignment. Make sure you submit the assignment before the due time. Good luck for your final exam. I hope all of you can pass the exams with good marks. See you. Bye guys.